A huge amount of our energy generated is used to power lighting appliances. This comes as no surprise as almost every single interior space such as LT2 as seen here and our classrooms requires proper lighting to facilitate a proper and conductive learning environment. These appliances convert electrical to light energy, but this process is not 100% efficient. Some energy is almost always lost as thermal energy to the surroundings. All this energy wastage not only costs us money, all this wastage add up and we could really reduce the onset of global warming if we have less of such wastage, which would minimize the power we need to generate. Thus, our group has devised a way in which we could harness the thermal energy wastage of lights for useful work. Since only light from the lower half of a ceiling position fluorescent bulb feeds into the room, our group plans to insulate the upper proportion of the fluorescent bulb to trap the thermal energy released and channel it into the hot end of a PLCR chip. Electrical energy is generated by the seeback effect, and this electricity can be used for powering useful work. The current is 0.5 mA and the voltage is 0.2 volt. So the actual power is 10 to the power minus 4 volts. Then we find the CE from the internet. We use the knowledge learned in week 8 and we got CE is 0.039. Then we can get our efficiency, which is about 10%. For future improvements, we can harness this energy from the PLCR chips and store it in a battery to supply power to an electrical circuit, where we can then use the energy to power other electrical appliances. In conclusion, by doing this, we hope to reduce the carbon footprint by tapping on an otherwise wasted form of energy.